Integration of these functions is what we are going to see. We have been seeing the introduction in the last lesson. Now let us see how do we use those properties to evaluate such integrals. Okay, so recall from the first lesson that we said if you have x power n dx, the same as you increase the power by 1, you divide by the new power. If it has no limits, you add a constant of integration. And we said if you have limits, now we evaluate this function in words. Then if you have a constant dx, the same as x plus a constant, then this one we have seen if this is linear, if the highest power is 1, then we can interpret it in this way. So let us start with this one. Now we have integral of x dx. Now we start here, our power is 1. So here I said our n is now 1. What we do? We increase the power by 1. So this will be now x 1 plus 1 over 1 plus 1. Which will be, okay, that's a constant of integration, and this will be x power 2 over 2 plus c. We stop at that. Then when we come to this, is that our n is 4. So this will be now x power 4 plus 1 over now 4 plus 1 plus c. This new power is what you divide down. But when you are much better enough, you don't need to do this. You just see this is going to be 5 over 5. So this will be now x power 5 over 5, then plus a c. Why are we putting the c? Because we don't have limits. When I come to this instead now, we have the constant. This is the idea we have. So this will be the same as 5x plus c. Now, this is our constant k. The idea here is there is x, but the x is to power 0. So when you increase this power by 1, here is 1. This will be 1 also. X power 0 is 1. And you start this, there is a silent 1 here. So what we are doing there in simple terms, we have this. This one instead is going to be a 5. So our 5 is equal to this. So when you increase this by 1, divide by the new power, that's why you have 5 power x. When you add it, 0 plus 1, you get 1 over 0 plus 1, which is 1. That's why we are having this. Okay. The same idea here is that there is x power 0, so this will just give us x, then plus a constant of integration. Now here, there are two ways. You can separate this and integrate, or you can use this idea. I'm going to use both. So if I say this is going to be now integral of 2x dx, then plus, I'm separating, then plus integral 3 dx. So there you can increase the power. So this one is power 1. So this will be now 2x squared over 2. And increase the power by 1, we get 2. Divide by that new power. Then plus this one is 3x. Then plus a constant of integration. And this will give you, when you simplify this 2 will cancel like this. And you have x squared plus 3x plus c. The alternative was, if this is linear, 2x plus 3 dx. Here, we said if it's linear, you can evaluate it in this term. By increasing the power by 1, you get a. So this will be now, you get a, instead here our a, the coefficient of x is 2. So you get 1 over 2. Now, we get 2x plus 3. Now we start the whole bracket is having power 1. So we increase it by 1, we have now 2 over the new power, which is n plus 2. As you see it here. You increase the power, then divide by that power. Then plus c. This is when you simplify. We get our quarter. Then 2x plus 3 power 2, then plus c. So all those two methods, this and this, they are very okay. If you simplify, you get the same thing there. Okay, when you come to this side now, we are going to use any you want, either this or this one, it's okay. So, but mainly use the idea of separating. So we are doing 4 dx, now minus integral of 5x dx. Now so we have x. This is the constant. We have now for x, then minus, you see it's power 1. So we're going to be having 5x, increase the power by 1, we get 2, over the divided by the new power 2, then plus a constant of integration. You see if it's simplified, this will be 5 over 2 x squared plus the constant of integration. As simple as that. When you come this now, we start this one, we have limits. These ones we are not having limits. That's why we are putting the constants of integration. But here we have limits. Okay, let us see how we integrate this. This one is x power 2. So we say this will be now 3. Now you increase the power by 1, you get 3. Divided by the new power 3. Then plus 2. We increase the power by 1 is to the power 1. So we get 2 over 2. Then this time we have limits. We don't put down the constant of integration from 0 to 1. And now this will be, start this one and this cancel. This and this cancel. This will be x cubed plus x squared from 0 to 1. We say we substitute the upper limit first. So when I substitute the upper limit, where there is x, I'm putting 1. So this will be 1 cubed plus 1 squared. After that, we subtract when we put in the lower limit, which will be 0. When I put here 0 cubed, then plus minus 0 squared. Then I cross that. We substitute the upper limit minus when we substitute the lower limit in that function we have got after integrating. So 1 cubed is 1. 1 plus 1 is there, we are going to have 2. Minus here we have 0, and our answer will be at 2. Okay, so that's our answer, which is going to give us 2. When I come to this now, this is the function of t, so this one is called the t. This will be the x's because we had the function of x. Just that our power is now 3. So increase it by 1, so this will be, when you increase this by 1, you get 4, divided by this new power. Then we have limits from 1 to 2. And the substitutes, now this will be, we substitute the upper limit, so when I put now 2 power 4 minus over 4. We are putting 2 here over 4. Then we put in 1 over 4. The whole over 4. So then we simplify that. 2 power 4 is going to be 16 over 4. Then minus 1 power 4 is 1. And you see if we simplify, we shall have 16 minus 1 over 4, which will give us 15 over 4, and that will be our answer there. As simple as that. Then when you come to this, now you see that this one is the denominator. It's the denominator, but we said our power rule works if it's in the numerator. So we use the idea of indices and we push it up. So when I push it up, it will be now integral from negative 1 to 1. We said if you take this up, the power changes. If it's negative, it becomes positive when it goes up. If it's positive, it becomes negative. Now, this one is negative. When I take it up, I'll be having now x power negative 3 dx. So now that is the function. Now it's like our n is a negative 3. Still increase the power by 1 divided by the new power. So this will be now x power negative 3 plus 1 over negative 3 plus 1. The limits from negative 1 to 1. And this will be now x power negative 2 over negative 2 from negative 1 to 1. And this substitute, okay, we can push it down. This will be now negative 1 over 2. When I take this up, then a square from negative 1 to 1. Why? Now I'm taking this negative down. When I take it down, it becomes positive. This negative, I take it up like that. Remember, there is a coefficient 1 here. When you multiply negative down and up, negative 1 times negative 1, this will be negative, then this will be a positive. Then from there, I can put in our limits. So if I'm putting my limits, I'm going to be adding negative r half. You can pull this negative r half out, then you substitute in 1 over 1 squared minus 1 over negative 1 squared. And instead all of this, 1 minus 1 is going to give us a 0. Okay, so now when we come to this, I'm going to leave this halfway. Then this one is the denominator, so you take it up. So it will be now integral of x plus 1 by -2 dx from -2 to 2. And now, here what happens, there are two ways. Now this one is in a linear form of this. So increase the power by 1. When you increase here by 1, you get x plus 1 or -1 over -1 from -2 to 2. And I think you can easily substitute in there. So this will be when you substitute 2. Now the upper limit we have, when we put here 2, we have 2 plus 1 or -1. Then minus, when you substitute -2 plus 1 or -1. Then you can easily evaluate this. It's going to be 5 minus. When you take this down, it's going to be 1 over -1. When you take it down, -2 plus 1. Remember, we have x power -1 is the same as 1 over x when we take it down. That's why this is 2 plus 1, which is 3. When I take it down, I get this from this idea. Then this is -2 plus 1. When I take it down, I get this power 1. The 1 is there. So negative and this negative, we shall have now a 5 now plus a 1, which gives you 4 over 3. Okay, so that's the idea. When I come to these ones, the same idea. Let us see what happens. So we are integrating, this one is power 5, power 2, then this is the constant. So this now, you can integrate them at once if you don't want to separate. So let's look at this. This will be increase the power by 1, you get 6. Divide by the new power, 6. Then minus 3. Increase the power by 1, you get 3. Divide by the new power. Plus, when you integrate this, you see that it is x power 0. Increase the power by 1, you get 1. Divide by the new power, which is 1. So you get 5x. You don't have constant, and that will be the answer. Now, when you come to this, you start we have this and we are dividing. So this one is done by separating. You say this will be now my integral will be. This one means the integral. So my integral will be now x power 4 over x squared. This denominator is for all. So it divides this, and also divides that. Then minus 3x cubed over x squared. Then plus 1 over x squared. The all respect to x. Okay, when you divide this, you get the integral of x squared minus, when you divide this, you get 3x plus. Now this one, to integrate it, we have to take the power up. That's going to be now x power -2. Now the all dx. Now I can integrate at once. This is the power 2. Increase it by 1, you get x power 3 divided by the new power. Then this is 6 power 1, increase it by 1, you get 3 x power 2 divided by 2. Then increase this by 1, we shall get, when you increase this by 1, you get x -1 over -1, then plus c. Simplify it, you get x cubed over 3, then -3 over 2, x squared. And when a negative divided by a positive, you get negative now 1 over x plus c. When we check it, I take this x down. This negative and negative get positive using this idea here. That's why I have that. So, that's it, members. I wish you well. Okay, so members here. We forgot a -1, this -1, this is over a -1, and this is over a -1. So this -1, you divide it here, you get a negative. Then also, this -1, you divide it here, you get a positive. So this negative divided by this negative, you get a positive. So we have now, this is now going to become, this is becoming now, sorry for that error. becoming negative 1 over 3 minus 1, which would be negative 4 over 3. So that's it.